Good afternoon, dear guest speakers. Welcome to our Linking Real-World Data with Reimbursement Decision web-based conference. My name is Katarina and I'll be the moderator of this event. On behalf of Kakushin Group, I would like to thank you all for joining us today. At the very beginning, I'd like to inform you that approved presentation files and the full recording of the web-based conference will be available after the webinar. We will send you all the information as soon as possible. In order to enhance the experience of this web-based conference, I would like to encourage you to ask questions from our speakers. You can raise your hand anytime during the presentation. We will turn on your microphone and you can ask your question or share your comments. You can also send in your questions through the chat window on the bottom of your control panel. Now we can move to our agenda. Let's review who are our speakers. I'm honored to introduce our speaker lineup for today at 2 p.m. shortly after my speech ended. Stefano Viaggi is going to be the first speaker delivering presentation on real-world data providing a new source of clinical evidence. Second speaker, Townhill, presenting on real-world data and clinical trials. Third one is Stephanie Manson, introducing you a topic on data revolution in HEOR. And the very last speaker, Nigel Hughes, who has prepared a presentation on developing a quid pro quo around real-world data for stakeholders. Look forward to all of them. I believe every single presentation will spur a great discussion afterwards. So now, without any more delay, I would like to get started and introduce our first speaker. It's my pleasure to introduce you Stefano Viaggi. Stefano is a Director of Marketing and Real-World Data Solutions at Medidata, a company focused on observational research for the life sciences and specialized in the design and management of multi-center international observational studies and patient registries. With a special talent for innovation and strategic thinking, Stefano has been working in the pharmaceutical sector for over 25 years, providing statistical and epidemiological consultancy and project design for multinational pharmaceutical companies, clinical research organizations, and CME providers. He holds a university degree in statistics at the University of Padua, is a co-author of several clinical research and epidemiologic papers, and has a special interest in forecasting and collective intelligence. Stefano, we are glad that you are here with us today. Please, you can start with your presentation.
Okay, thank you very much for your introduction. Thank you for inviting me to speak about real-world data in this interesting webinar session. Okay, in my presentation I will provide an introduction about real-world data in order to share common definition and some thoughts about why and how real-world data are providing a new source of clinical evidence today. Then I will go through what are the major concerns about real-world data and some recommendations to deal with them. I made some research on PubMed about the quantity of published papers with some kind of real-world related keywords. It's easy to see that the interest about real-world data is very trending because there's an evident growth in the numbers of published papers. But does it mean that randomized clinical trials have lost interest? No, it's really not the case because the number of published papers about randomized clinical trials is much bigger. Here you can see that real-world data papers seem to disappear. Randomized clinical trials still remain the main source of clinical evidence today. So does it mean that real-world data attention is just trending, fictitious, or not so important? Let's give a look to data from another point of view. Instead of considering the cumulative number, let's look at the ratio between real-world data and randomized clinical trial published papers. In the last year, we have that nearly for every 3 papers published about randomized clinical trials, there is 1 about real-world data. So I can say that the trend is real. This introduction just to say mainly 2 things. The first one is that there is a real growing interest in real-world data in recent years. And the second one is that we have to be careful when looking at data in order to get the right conclusion. Okay, let's move on and let's see some definition. What are real-world data? Using the Ashford definition, real-world data is anything other than randomized clinical trial generated data. In general, real-world data are observation based on what happens in a real-life setting, where the researcher does not control or influence the observation of the data. Real-world data are also defined by three types of characteristics: the type of outcome, the type of evidence the data provide, and the type of data source. We can see real-world data from two common perspectives. The researcher's perspective that considers real-world data as a measure of understanding healthcare data collected under real-life practice circumstances. And the payer's perspective that considers data from real world to understand what we say is the value for money. Considering that real-world data are characterized by the type of outcome, this brings us to the outcome research world. Outcome research, as you know, is a research addressed to evaluate what comes out, the end result of the healthcare intervention. Outcome research is responsible to export the evidence coming from randomized clinical trials in a wider setting, considering outcomes that could be clinical but also humanistic and economical. So we start to speak about the idea of effectiveness, a concept that can be addressed with the evidence of randomized clinical trials alone. The process of generalization and exportability of the evidence can go even further, involving the idea of efficiency. We can start asking if an healthcare intervention does work or not, but later we have to face the question if it is worth in a larger population and in the economical context. The second type of characteristics that define real-world data is related to the strength of the evidence supported by real-world data. We can observe that in the well-known pyramid of the evidences, meta-analysis and randomized clinical trials stay at the top spots, but just behind them there is a variety of study design that are typical observational methods. Today we tend to consider the pyramid from another point of view, with the real-world data and observational studies that are the new, broader evidence that's supported by randomized clinical trials. It's from 2008, so not so many years ago, that Professor Michael Rawlins at the Royal College of Physicians firmly underlined that we need a new kind of evidence that surpassed the one of randomized clinical trials. His provocative paper was quickly cited all around the world, giving life to the concept of real-world evidence. Speaking about evidence, when do data become evidence? Evidence infers a degree of actionability, whereas data are just effects. Data, we can say that data are objective observation, while evidence is the organization of observation to be informative. Evidence drives the decision based on the interpretation of the data. Building the real-world evidence requires the systematic, unbiased collection of data. The accuracy of the data, the strength of the study design, and an appropriate organization to understand data are critical success factors needed for a reliable evidence from real-world data. In order to complete the definition of real-world data, we can characterize them by the type of data source. We can encounter real-world data in database, patient chart review, registries, core studies, and so on. The majority of this data source relate in some way with observational research methods. For this reason, I could say that real-world data are essentially data collected with observational research methods. I think many people remember this wonderful movie, Sliding Doors, which was directed around the concept that time has a tremendous influence in our lives. I think it's quite similar speaking about real-world data. A very important distinction about real-world data source type is related to time of observation. So we can distinguish between retrospective and prospective real-world data. Retrospective data can be sometimes easier and cheaper to collect, but the trade-off is the risk of biased information. We'll see more on this later. We can say also that real-world data share a sort of overlapping with epidemiology and pharmacoepidemiology. Post-authorization safety study, for example, can make, this is a slide. This is a map of interaction where we can say real-world data stands. So why real-world data are so interesting today? Aside from the question of why there is a current move to collect real-life data, there is also the issue of why the move is happening so quickly, and particularly receiving so much attention. Several factors are driving the trend. Randomized clinical trials are also recognized as the gold standard for establishing efficacy, operating in an idealized environment, and can only measure efficacy in limited populations. As such, they cannot provide a true indication of effectiveness. Second, real-life data can be obtained from sources that cannot be included in randomized clinical trials and provide additional insight into areas such as epidemiology or cross-data from a more naturalistic environment. Compliance, adherence, and cost insights can also be obtained. But perhaps the most important driver of the push is that decision makers are expressing a much bigger interest in real-life data on effectiveness than they ever done before, to better manage uncertainty at the time they are making a reimbursement decision. Decision makers looking to make coverage and payment decisions may rely on multiple benefits from real-world data: diverse population, broader range of outcomes, compliance, and adherence, just to name some of them. According to a recent study conducted by IMS Health in 2013, real-world evidence had a relevant impact in decisions about medicine in a variety of ways. Furthermore, an interesting finding of this research showed that pharma play an important role in generating real-world data, actively contributing to healthcare decisions. It's worth considering that in Europe, the source of impact of real-world data ranged in a variety of ways, also among different European countries. For example, I am from Italy. I've been attracted by this figure looking at the Italy bar, which brings evidence that the large majority of real-world data is when a drug is actually launched in the local market. I think this is another important recent fact that easily explains why real-world data are drawing so much attention today. The European Medicine Agency has recently introduced the concept of adaptive licensing. Significant data generated from real life benefit both the time of licensing, that could be shortened, and the amount of real-world information on patient experience and active surveillance. Okay, this is just an overview about the definition and the reason of this trend. I think that some word occasion should be spent also about what can be the major concern about collecting real-world data. The most significant concern when using real-world data is bias. Whereas in experimental randomized clinical trials, randomization is always nearly for controlling bias, in observational studies we can meet systematic bias, mainly in the form of misclassification and confounding. Let's give a quick look to what they really are. Misclassification is a form of bias introduced by an error in the classification of the exposure or the outcome. For example, identifying subjects as having experienced the disease when they have not. It's easy to understand that it's quite a big problem. Confounding is the other main problem about bias in observational studies. Confounding occurs when the exposure-outcome relationship estimate is biased by the effect of one or several confounders. There are many types of confounding, and we can have problems with dealing with them. Strategies to adjust for confounding vary depending on whether the potential confounders are measured or not in a given database. If confounders are measured, then usual basic strategy to account for confounding include those concerning study design, for example, restriction and matching, and those concerning data analysis, such as standardization, stratification, and so on. If the confounders are not measured, things can be more complicated, but both study design and data analysis can provide techniques for dealing with them. So just to summarize, the main message here is that if you know your demos, you can face them appropriately. So we have basically two main weapons at our disposal, study design and data analysis. I would briefly would like to come back to the concept of sliding doors movie we have seen before. When considering to use retrospective versus prospective real-world data, keep in mind that with retrospective data you can use only one weapon, the data analysis. In other words, with retrospective data we miss the opportunity to use the powerful weapon of study design. Some words about study design. I have to say that study design is a powerful weapon for sure, but it's also a complex issue. No one approach is always better than the other, and it really depends on each specific research question. The research question is central, I can say central in the study design approach. The research question is the uncertainty that the investigators want to resolve by performing the study. The challenge in finding a research question is defining an important one that can be transformed into a feasible and valid study plan. This is an approach it's called FINER, and the FINER approach can be useful because it gives guide to look for research questions that is feasible, interesting, novel, ethical, and relevant. Another checklist is provided by NCPP, and it suggests to look for why the study is conducted, the objective of the study, the target population, a formal hypothesis to be tested, and an eventual a priori hypothesis. These are just quick tools to check for a good study plan. Obviously, I have no time to go into details of what about study design, but just a few things to remember is the main point, for example, that distinguish between an experimental study and observational studies, that the exposure, active or passive, determines if the study is experimental or observational. We speak about active exposition or passive exposition. Observational studies can be then classified as descriptive and analytical, depending on the aim of the studies. Descriptive when designed to describe the occurrence of an outcome, and analytical when designed to study the association between the exposure and the outcome. There are many types of observational study design, obviously. It very depends on the objectives. The main use are cohort, cross-section, and case control studies. For sure, we can skip these two notes and go directly to conclusion and some point just to summarize. We have seen a quite general overview about what real-world data are and why they are attracting an increase in interest. We have seen that we need to use some caution when facing bias and confounding and how to approach them with data analysis and study design. I think main point to remember are this. Interest in real-world data is rapidly growing as never before. Simply put, real-world data are anything that is not interventional and can be characterized by type of outcome, strength of research design, and type of data source. We're speaking about definition. Real-world evidence is becoming essential for sound coverage, payment, and reimbursement decisions. The other point are that randomized clinical trials remain the gold standard for demonstrating clinical efficacy in a restricted trial setting, but other designs, as observational registries and the longitudinal core studies, can contribute to the evidence base needed for coverage and payment decisions. Real-world data are key for speeding up drug licensing time, while enabling wider experience and surveillance at the same time. And the last point, I think that while use of existing database are sometimes considered as a quick and cheaper access to real-life evidence, confounding issues have to be properly managed. Longitudinal data rank higher in the evidence hierarchy and permit to control bias both with proper study design and data analysis. Okay, thank you very much for your attention. This is the end of my presentation.
Okay, Stefano, thank you very much for your presentation. It was really interesting. Thank you very much for your insights. And now I would like to open the Q&A session. Dear attendees or other speakers, please submit your questions through the chat window or raise your hand so we could turn on your microphone. Till then, I would like to thank you again for a very interesting presentation. And right now, it seems that we have a question from the audience, and I guess, Stefano, you can also see it on your screen right now. And I'm going to read that question. From the figure you have shown, the use of real-world data is most common in the UK, followed by the USA. And what about the emerging markets?
But emerging markets, I have no data at the moment, I have to say, but I think it will increase. It will increase because more and more data are observed also in that markets.
Mm-hmm. Okay, thank you very much. And I can see that we have one other question. And this question is, isn't pharmaceutical research becoming too analytical with this real-world data?
Oh, I really don't get the point of what it could the person who asked the question mean when saying that the pharmaceutical research becoming too analytical. I think that real-world data are adding new evidence, as I said, so new data and new evidence, other point of view, and they complement the drug development process. So they are additional information that have an important value for the drug development.
Okay, Stefano, I hope this answer was sufficient. Well, it seems that we have no other questions for you, so I would like to thank you one more time, Stefano, for your presentation, and we are very happy that we have you here.
Thank you.
Okay, next on our agenda, I would love to welcome and introduce Jenny Townhill, Clinical Trials Manager from European Huntington's Disease Network from the UK. Jenny obtained her PhD at Cardiff University in 2004. She has more than 10 years experience of working with complex research databases and coordinating commercial and non-commercial clinical research in Huntington's disease. She's a member of the European Huntington's Disease Network, Clinical Trials Task Force, the UK Huntington's Disease Network Steering Committee, and Cardiff University's Brain Repair Group. Jenny, thank you very much for joining us today. Please, you can start your presentation.
Okay, thank you very much. Okay. Can you see the large display or can you see two small slides?
We can see two small slides right now.
This one, is that better?
Yes, okay, now it's full screen. Okay, perfect.
Okay, great. Okay, so thank you very much for inviting me to speak today. I'm going to talk about really some studies that we've been conducting using real-world data and some of the applications for this data that we've used so far. I'd welcome any questions at any stage during the presentation. Okay. So very briefly, I'm going to mention what Huntington's disease is because it's relevant to why we set up these data collection systems in the first place. And then I'm going to talk about how the registry and enroll studies can be used as a platform for research. So this is real-world clinical data collected in parallel with routine care appointments often, and also how we've used that to facilitate clinical trial planning and expedite trial recruitment. So Huntington's disease is a relatively rare disorder. It can be classified as an orphan disease. There's an incidence of approximately 1 in 10,000. It was first described at the end of the 19th century by the man on the slide, George Huntington, and the gene responsible for causing the disease was actually identified in 1993, and it's a single gene disorder caused by a CAG repeat. It's important because it's some of the mechanisms that are behind Huntington's disease can also be applied to other diseases, other genetic diseases. So we can extrapolate the findings from our studies in HD to other neurodegenerative disorders. Symptoms for HD include motor impairment, cognitive impairment. It's currently incurable, so there's death around 10 to 15 years after symptom onset, which is typically in midlife, so around 40 years old. And at the moment there are very unsatisfactory treatment options, so no treatments or cures. The treatments that are available are only symptomatic, and even though they can control some of the symptoms, there are often undesirable side effects. So one of the challenges that the HD research community faces is the lack of sensitive disease outcome measures to track disease progression. So this is the registry and enroll HD clinical studies. The sponsor is the CHDI Foundation. This is a US foundation that funds global research into Huntington's disease, and they fund everything from bench to bedside. They have drug development streams as well as funding clinical research projects. Registry and Enroll HD were intended to provide a platform for this research. They're multi-language data collection platforms. So as well as the data collection platform, we also have some infrastructure to also support and facilitate global clinical trials on Huntington's disease using the data that we collect through these platforms. And I'll go on to let you know a little bit more about exactly what we collect and what we use it for. So really the main vision and goal behind these studies was that they would be an observational studies and an enabling platform. So they're flexible and adaptable, and we can add on data collection to the core data set. It's an observational study that's prospective, dynamic natural history cohort, and it's open to everybody affected by Huntington's disease. We also collect data on community controls and companions or carers of patients. So we gather data independent of a specific hypothesis. We also collect biological samples, for example, key information about the genetic status of the person. We characterize all facets of the disease by inviting patients to attend for annual assessments, and these annual assessments collect the same data points at each visit. We can also use this platform for hypothesis testing, so we have this prospective targeted data gathering, and we can change assessments or add on assessments to our core data set. So in summary, really, there are three main priorities of this clinical research platform. The first, really, and the foremost, is to enable clinical research. Sub-studies we can add on to this core data set, for example, rating scale validation. As I mentioned, one of the major problems in research in this disease area is that the outcome measures are not particularly sensitive. We can look at experimental medicine studies and also accelerating clinical trial recruitment using the information that we hold on this database. As it's a longitudinal observational study, it will help facilitate our understanding of the mechanisms behind the disease, which aren't fully known at this stage. And also, another important aim really is to improve the care that patients have, so we can conduct outcomes research and promote standards of care through this platform. This is just a screenshot of the entry portal to the Enroll HD study. We also offer investigator training through here, so we offer standardized training for the key assessments in Huntington's disease to try and reduce variability in the data collection that we have. This is a very busy slide, but this is really just to show you some of the assessments that we have collected. So we collect things like all information about medical history, demographics, current conditions and medication, as I said, the genetic test. We collect blood and urine for biomarkers, and cognitive assessments, psychiatric and behavioural assessments, family history. We collect family trees on participants, and we have the ability to link separate participants' data through in our web portal that are related. So we can map relatives and also look to see whether their symptoms and interventions have different effects on members of the same family. So it's slightly confusing that we have these two studies. So Registry was launched in 2004 in Europe, and it is the core study of our European HD network. Enroll HD was launched in 2013. It's intended to be a global study. It was launched in North America, Canada, Australia, New Zealand, Latin America, and now European sites are all in the process of transitioning to Enroll HD. So all the registry sites by the end of next year will be on the Enroll HD study. So Enroll HD built on the registry database and the registry data collection, and slightly changed a few outcome measures and involved the world, basically. So it's a global study now. Again, it's data collection within routine clinical care. So the idea was that we'd approached existing HD centres and asked some of these assessments they were already doing as part of the patient standard care. So we asked them to just extend their routine data collection and take part in the studies that way. Again, just to summarise, this is they're trying to compile uniform clinical data and biological samples, building this comprehensive database that is accessible to any HD investigator worldwide. So we make this data available to anybody who has a project proposal. They can also apply to access biological materials linked to clinical data set. This facilitates clinical sub-studies and the development of the validated assessment tools that we need. We need the validated assessment tools in order to get reliable outcome measures for the randomized clinical trials. And again, to foster good clinical care and improve health outcomes for both patients and families is really important. Expediting recruitment into future global clinical trials of candidate therapeutics is another really important aim. As I mentioned before, the CHDI Foundation also funds drug development, and it's hoped that if a promising candidate comes along, that we will have this global cohort that we have well characterised, ready to enrol into a clinical trial. Currently we have more than 13,000 patients enrolled in registry across Europe, and to date for Enroll HD there are more than 700 patients enrolled. Just to show you the geographical coverage of registry, we have 20 countries, 16 European and 4 non-European. We have Russia, Singapore involved as well, and I think China will be joining Enroll HD. Another feature of our database that you may not often find with observational studies is that we have a level of study monitoring. So we have remote monitoring and on-site monitoring for consistency and to verify the data that we collect. Every study site involved has an annual monitoring visit where we check consent and do some source data verification. And we also have medical monitoring to look at site trends, study site trends across the global cohort. So looking to whether a particular centre has certain effects that might be unique to that study site. So I mentioned we have this database and the biological samples that researchers can apply to use through data mining applications. So a researcher would submit an application through our portal. It would be reviewed by the Scientific and Bioethics Advisory Committee, which is the SBAC on this slide, and then the decision passed to Executive Committee. And if all are in agreement that it's a worthwhile project, the data and samples, if relevant, are transferred to the researcher, and an agreement is put in place. So far we've had numerous approved projects. A few of the notable ones are the drug survey on prescribing habits across Europe. So this looked at real world prescribing habits in all the countries that were involved in registry, and did a comparison of which drugs are prescribed in each country and the various costs. We've looked at different stages of Huntington's disease and how people manage those specific stages. There's been a comparison of the various depression scales, use of rehabilitation services in HD and the costs of those services. There have also been numerous biomaterials requests looking for biomarkers that might track disease progression, and also there have been some genetic studies, and I'll mention one of those a little later in my presentation. There have been more than 100 publications based on the data from registry. So as I mentioned, all registry participants are asked if they're willing to provide blood and urine samples when they enroll and at annual visits. And scientists worldwide can apply for access to this material. A scientist in the States has been long interested in identifying a genetic modifier for Huntington's disease. So whether it's a single gene disorder, the age of onset can vary greatly between people with the same triplet repeat in their gene. So there's obviously other genetic modifiers that come into play. And scientists have long been searching for different modifiers which may prove to be targets for drugs. So this is this modifier study from the HD-GEM consortium, and it really does show that size matters. So 830 samples from HD patients were analysed, and this is a Manhattan plot, and really all you need to be aware of is that there's no significant peaks on any of these coloured bars. When we looked at 1,138 samples, again this was not significant. So this is 1,138 samples from HD patients, which, as we recall, is still a relatively rare disorder. With 4,050 samples, we think we have identified a significant genetic modifier on chromosome 15 here in the blue, which everybody is very excited about because this could prove a new candidate for disease. And we're continuing this data collection, and more samples will be added to this data set when they're available, and this hopes to yield more genetic modifiers and more potential disease modifying targets. Another feature of the platforms Enroll and Registry is that we can run sub-studies. As Enroll is relatively new, we're going to talk about the sub-studies that have been running through Registry, and these have been looking at novel assessment tools and validation of these outcome measures. So the behavioural working group of our network has been looking at tools to look at the symptoms for apathy, irritability, and frontal and executive behavioural problems. We have had an additional study linked into registry called the Lifestyle Factors Study, so the core registry data set is used and an additional assessment is added on, and this assessment all asks about people's hobbies, lifestyle, environmental factors that may have an impact on the disease. Physiotherapy outcome measures study. This has looked at specific physiotherapy measures for Huntington's disease, as there previously haven't been any defined as best practice. And the quality of life study, again, there's been previously no specific quality of life measure for this disease. There's only been generic measures. So this is an attempt to validate an HD specific quality of life questionnaire. And more than 500 patients have already been recruited to that study. Another important component of the data and bringing expert investigators together is that we can prepare guidelines for certain disease management. So this is the standard of care guideline that's been developed using the registry database and the network. Sheila Simpson and Daniela Ray were the lead facilitators of this group, and they brought together experts from all over Europe working in different areas of Huntington's disease and have published some standards of care guidelines, one on physiotherapy, one on nutrition, dentistry, oral feeding, guidance for speech and language therapists, and guidelines for occupational therapy. And these guidelines have all now been published in Neurodegenerative Disease Management and are open access. For Enroll HD, there's a care improvement committee that will use the data that's gathered on our platform. So the idea is to identify interventions that are relevant to patients, to their well-being, and to their general outcomes. So this is just following the cohort of patients across the years and just seeing how they're doing. But what we really want is reproducible interventions, to find which interventions have an impact, and then to disseminate best practice across our network of clinical study sites, and to also share these with the patient associations. So for this, we have the case mix. So this is the data that we actually collect routinely: age, gender, genetic information, how long someone's had their symptoms, when they were diagnosed, education, and various other lifestyle factors. For each visit, we also have additional factors such as any medications they might be on, nutraceuticals, supplements, if they're having any support services, psychiatric speech therapy, etc. CSRI form collects information about what interventions they might be having from a health economics point of view. So if they have to have routine hospital visits, or if they require a carer to come and stay with them in their house, or walking aids and those sorts of things. Into this mix, we're also going to be looking at centre effects. So this is whether there is an actual effect of the study site a person attends, where that centre is, the number of patients that he might care for, and anything that might be unique to that centre that could be having an additional impact on a patient's outcome, health outcome. So the outcomes that we look at would be the movement symptoms, any behavioural, cognitive, quality of life, depression, and those sorts of things. And we also collect information about the caregiver and caregiver burden and caregiver stress. On to clinical trials. Really, this is something that's becoming more and more important, and we're currently working with 3 sponsors and CROs to try and facilitate randomised controlled trials in Huntington's disease. We have set up a clinical trial task force where we collaborate with industrial partners, and because we have this bank of experts in Huntington's disease that all support our global registry and enroll, we have these experts sit on the clinical trial task force, and we can advise industry from aspects of protocol development and feasibility all the way through to supporting trial recruitment. So external partners can approach the network and request that we have support, and they can use the database. I'll skip over this slide. So really, to expedite clinical trials for feasibility and recruitment, we have this clinical database, and If a sponsor approaches us and says, well, we would like to test this drug on 5,000 HD patients in the UK, we have the data at our fingertips to say, well, actually, looking at your key inclusion and exclusion criteria, there are only 500 patients in the UK. You're going to have to go to other countries if you want to recruit to target. That's just one example. So from our database at any time, we can pull up the number of potentially eligible patients at specific sites in specific countries and globally. We can identify suitable participants using key inclusion and exclusion criteria for a specific trial. So we can provide numbers to sponsors of how many patients there are available. And then once the trial is up and running, we also assist sites in their screening activities. So we would provide them a list of the patients that might be eligible for a trial at their site, which really facilitates, I suppose, pre-screening. We can use the data that we have from supporting previous HD-specific trials to look at recruitment projections and planning with our industrial partners. We have nearly 10 years experience with certainly a lot of the European sites. We have experience on how they have performed on HD-specific trials, which gives us a real powerful tool to estimate, startup timelines for a specific site, recruitment rate, screen fail rate, site dropout rate. We have the real world data for all these things based on our experience now with all these centres. I'd just like to acknowledge really the CHDI Foundation for their generous support of all of these projects and central coordination and language coordination of the EHDN and most of all the HD patients and families. Thank you. Have you got any questions?
Thank you very much, Jenny. It was really interesting presentation. Now again, I would like to open the Q&A session like before. So dear attendees, you've got the options how to submit your question. You can use either the chat window, or you can raise your hand and we will turn on your microphone. It seems that we have few questions and we will see it in the screen shortly. Yeah, so I'm going to read the question for you, Jenny. How to build a comprehensive database in order to be accessible to any HD investigator worldwide? Is there a template for that?
I'm not sure really specifically about a template. We worked with a company who's experienced in clinical case report form design, but then what we have is an area of our portal where people can submit project proposals. So someone would submit a specific proposal listing the data that they would want access to and what they want to do with it. That proposal is submitted and reviewed by the committees, and then the data is released to that person. For each investigator, each study site, they can view their own data at any time. I don't know if that really answers your question.
Okay, thank you very much. And now we have a question from somebody from the audience, and the question is, you mentioned the US, the UK, Canada and Europe. Does the number of patients you have shown us include Asia?
We have a small number of patients in Singapore, and we are hoping to expand to China and Japan. We have very strong links to Singapore, and I think we've also had interest from Malaysia, so we would like to include more of Asia going forward. We have Russia joined the network a couple of years ago, and we have increasing numbers of patients in Russia too.
Okay, perfect. Thank you very much, Jenny. And we have a question from Nigel Hughes, and he's asking, how is the program funded?
Okay, so the program is funded by a private foundation called CHDI, and they have funded every activity solely from the beginning of the project, so since 2004.
Okay, perfect. Thank you very much. So let's wait for a few more seconds if there are any other questions from the audience. Okay, it seems that we have no further questions. So in this case, thank you, Jenny, for being here online with us and for your presentation. Thank you very much.
Thank you.
And now I would like to ask Mr. Hughes if he's ready to proceed with his presentation, because Stephanie Manson is not here right now. She hasn't arrived. So Nigel, could you do your presentation right now? Well, it seems that we don't have Mr. Hughes here also.
Hello? Hi,
Nigel.
sorry. Yep, sorry, I was on mute at this end as well.
Oh, okay.
My apologies.
Okay, Nigel, can you proceed with your presentation, because Stephanie Manson is not here. Okay, so I'm gonna just quickly introduce you, and then you can start your presentation. So Mr. Nigel Hughes, I'm really honored to introduce him. He's currently Global Director, Marketing and Health IT Strategy Leader in Janssen Diagnostics, a former UK NHS healthcare and voluntary sector professional working in the pharmaceutical and diagnostics industry with a broad experience in the blood-borne virus market based on professional heritage in the viral hepatitis, liver disease and HIV fields spanning 30 years. Formerly working for Roche, Gilead, Novartis and now Janssen, he's now focusing on strategic marketing for new diagnostic solutions for personalized medicine via bioinformatic tools, health information technologies, and biomarkers in infectious or chronic diseases. In particular, leading health information technology strategy for clinical registry and electronic health record implementation and expansion in the US, Europe, and wider, as well as working to develop overarching responses to the need for real-world data in pharma. So Nigel, welcome, and you are ready. If you are ready, you can start with your presentation.
Thank you very much. Hopefully you can see the screen. Thank you, Katerina, and thanks for inviting me to speak today. So I'm talking about developing a quid pro quo around real-world data for stakeholders. I'll talk a bit about really from a pharmaceutical diagnostics kind of perspective, but I'll try to cover kind of three aspects really. This kind of broad subject around real-world evidence that Stefano has very nicely covered, and I think we saw from Jenny already in the previous presentation in terms of a real-world use case, but also some of the use cases that, some of the illustrations from the work we're doing here fairly broadly, and then I'll end on maybe some tips and some kind of toolkit ideas in terms of how to think about this related to real-world data. So moving the slide, just a quick mention about Janssen Diagnostics. We're a small organisation within Janssen, one of the many hundreds of companies within Johnson & Johnson. This quote, if you can see on the slide, is from Hippocrates, 460 to 370 BC. It says, "It is more important to know what sort of person has a disease than to know what sort of disease a person has." And it almost speaks to what Jenny was just saying about Huntington's disease, unfortunately. But really, what we're tasked with and what we're working on is developing personalized medicine tools and solutions that link to the drug pipelines in R&D within Janssen. And we're based here in northern Belgium, in New Jersey, and also opening office in China. We're about more than 200 people strong now, and we were formed just over 2 years ago. Mainly working on diagnostics, but we also have programs working around real-world data, real-world evidence, health information technology, and I'll talk a bit more about those later. Just some definitions. We already heard some from Stefano. The one I'm currently using is kind of real-world data is derived from clinical practice in an observational, non-interventional setting. It's not based on clinical trials, as we heard earlier. And then real-world evidence I'm defining is really real-world data obtained from the real-world setting, plus analytics. It's the generation of those insights, and I think that's fairly much broadly in line with what Stefano was saying in the first presentation. But this is the definition I'll be using in this talk. So, busy slide. I'm clearly well known for this, but just to talk about personalized medicine and really put some context to how we're viewing real-world evidence and real-world data is this triad of diagnostics, therapeutics and data. Clearly there's a lot of focus on drugs and new modes of actions and improving comparative effectiveness and enhancing outcomes and survival in therapeutics. We're seeing a real upsurge now in the uptake of diagnostics worldwide, wanting to improve diagnosis rates, enhance disease monitoring, staging and grading of disease, stratifying medicine, stratifying patient groups, and obviously ultimately personalizing therapy. But all of this needs to come in with kind of the healthcare system and engineering it. We're using data and really all of diagnostics ends in a data point of some kind, and therapeutics, if you're talking about outcomes, you need some kind of data. So really we're looking at improving utilization, uptake of diagnostics and therapeutics. We need to look at enhancing the infrastructure of healthcare, particularly as the challenge as new technologies, new drugs and so forth come to market. Very importantly, improving clinical decision making, ultimately to improve outcomes. That's also linked to things like benchmarking and evaluating relative outcomes. It was a very interesting point from Jenny earlier about different outcomes from different clinical centres, and it's clear, we've seen this in many other diseases, that who you see and who you're treated by can have a significant impact on your outcomes. And also maybe linking this to things like biorepositories, but biobanking tissues and so forth, particularly for developing things like biomarkers and other types of diagnostics related to for instance, host genetics and other systems. So all of this triad really is around kind of common disease strategies and really personalising healthcare. And without any one of these three, we really probably don't have such a thing as personalised healthcare. It's a very busy landscape. I'm not going to go through this slide. It speaks to a lot of things that Stefano was saying earlier, but certainly that there are a lot of things that we need to get to grips with when we're now talking about data, and in particular this kind of bi-directional flow of data between those who are providing data or generating data, those receiving it and doing some insights generation. But it's really worldwide now, growing very rapidly, and we're seeing the digitalization of healthcare as we have seen for many other industries, from film and television and music, for instance, right through to finance and banking and so on. And as you digitalize anything, clearly business models can get quite significantly disrupted, and we see all sorts of new emergent trends and new entrants coming into the marketplace, and healthcare is now seeing this significantly with things like electronic health records, registries and so forth. Another busy slide, but just to reiterate that really we need to be thinking about longitudinal a collection of data, like was being presented previously by Jenny on Huntington's disease, and it's very much about it's life-reflecting data, and clearly also we've focused for many years now in this middle section around dynamic monitoring and disease management. When people are ill, what can we learn from the disease, its natural history, the disease states and so forth. It's the interventions we provide and their outcomes. Increasingly supported by new healthcare data and omics, all sorts of different types of data, not just genetics but metabolomics, proteomics and so forth. And so there's a wealth of data being generated biologically. Also, sadly, when people die, a lot can be learned from that as well. And that's the end of the spectrum, as it were, that we've really been capturing a lot of data. But more and more, we're looking to intervene early, far more on the left hand of the slide in the green section, when people are generally effectively well. Not just healthy controls, but it's kind of the so-called pre-disease state. So Alzheimer's is probably a good example that we talk about. We haven't got very good treatments clearly at the stage, and R&D has been very challenging. But if we could potentially have the holy grail of a treatment that could reduce your risk or even stop you from developing Alzheimer's 20, 30 years ahead, we'll need to be able to identify those individuals early. And that's a very different model and approach to what we generally do now, when people usually present when they're sick and they have signs and symptoms, and then we'll have to see how people will stay well, and also evaluate those people that are non-progressors, maybe even naturally, like for instance in HIV. So there's a lot of data that we can obtain from the so-called well population that we don't necessarily obtain so well now, and lots of lifestyle data as well as things like omics and so forth. And now a good example is people's buying patterns. So many grocery stores have reward schemes. They're collecting all sorts of data from you when you purchase stuff. Why are we not linking that data with your clinical data, for instance, so we get even more rounded view of you and in terms of your lifestyle? Ultimately, we're collecting data often in a clinical setting where you're seeing a physician for instance something like 15 minutes with your appointment, and that's really just a tiny snapshot in the overall longitudinal experience you may have with illness, unfortunately, and we need to understand much better what's going on outside of the 15 minutes with your physician in your real life. Moving forward, just in terms of where we're thinking, certainly within the pharmaceutical industry, but I think just could could well qualify within healthcare as a whole and organisationally. There needs to be some kind of framework for looking at real-world evidence, and that needs to be kind of end-to-end. It needs to look at all the individual sectors and internal and external partnerships that need to happen and be involved for data to be not only generated but communicated and then analysed, and that has to be organised, of course, with a kind of sense of purpose, and that comes back to what Stefano said at the start with asking a research question. It stems from what is it you're trying to answer, and you have to have some kind of strategic, organised response to that. Clearly there are a lot of tools and capabilities and platforms available, some better suited to certain types of data, some better suited to others. And also life cycles. Data itself has a life cycle, both temporally, over time, but also organisationally, in different areas of the organisation may be, required in early R&D at some point, but the same data may be useful for commercial, for instance, for the industry. And we need to be thinking more about a broader life cycle for data, and certainly linked working. And this will come back to this quid pro quo in a minute. It's important that we see data as having significant value, far more beyond just a kind of financial arrangement where we may buy data. We need to really see the value beyond that to all potential stakeholders, and much of this is around also kind of failing fast and learning quickly. There's a lot of things that can be done quite quickly and shortly that can inform you, and also inform you if this is the right approach in terms of accessing external or real-world data. And this is very different to probably how we develop drugs, which can be a very long process, and a very complicated process, but with a very standard, if you like, formula going through early development right through to later stage studies and into the market. And working with data is a very different kind of model for the pharmaceutical diagnostic industry. And importantly, how is this financed? And certainly one of the challenges, I think, is this early stages, nascent stage, as Stefano was saying, real-world data is kind of taking off, but it's still fairly early. It's quite often the projects chase the money, and rather than the money chasing the project, and that's something that has to be fixed very early. But ultimately, data needs to flow through the organisation like it's lifeblood, functional, but also nurtured to kind of best effect, to get the best advantage of accessing it. So what is this quid pro quo for data access? Well, I think very simply, accessing data and utilising it should be a bi-directional process. There should be value on both sides. So if, for instance, clinics, hospitals and others, patients themselves, are generating data and providing it to, for instance, the industry, then we could do that on a financial setting. We can just pay for it. Which is okay, that's happened for many years, but it doesn't really build much in terms of relationships, and also it doesn't build much more value than just a financial transaction. More importantly, is there things that we could do with that data that can provide value back to the people who provided the data? So for instance, on the left-hand side, the industry may be interested in market access, research and development, and trials and studies and so forth, all linked around outcomes. But meanwhile, for instance, if that data is brought in from many hospitals into, say, for instance, a registry, could that data then be analysed, insights generated collaboratively with the data providers, the clinicians and so on, and could that help them with things like benchmarking, research and audit? And this is particularly important for those providers, but also payers and governments and so forth. And so we should look very much, when we're looking to access data, understanding what all the stakeholder motivations are, whether we can generate a greater amount of value from that data, which will be useful for helping clinicians in terms of improving outcomes, managing healthcare and resource provision and so forth. And hence this kind of quid pro quo concept is extremely important, and we'll see in a moment. That's the kind of things that we're doing here at Manson Diagnostics, and I think similarly in other areas of the industry is starting to try and reflect that. So for instance, in the United States, we actually commercialize an electronic health record. You can see a lot of these laptops up here with the word Aviga. That's the brand name of the electronic health record. That's being sold to outpatient clinics, ambulatory care clinics that are managing people living with HIV in the United States. currently in that market only. There's a primary architecture, which is the transactional database. That's just managing the clinical data. Electronic health record manages everything you do, all the admin and billing, all the physician order entry, so all taking in lab test requests and bringing the results in and so forth, imaging and so on, referrals, doing all the clinical note handling and so forth, all the stuff you used to do in paper is now done, of course, digitally, and doing a lot of reporting as well. And our clinics are funded often by state and federal funds, something called Ryan White Care Act funding, which requires a lot of reporting because a lot of people living with HIV in those clinics don't have Medicare and Medicaid, they don't have private means of funding their treatment, so they require support via other means, so like grants, and that takes a lot of reporting. So we have a secondary architecture which is de-identified, and obviously all of this is under rigorous security and privacy requirements, both legal as well as operational. And we can create an analytics and research database off the back of the primary architecture, which then allow us to do looking at various studies that might be of interest for us, but more importantly, also do research, audit, and benchmarking, because all of the centres are linked up to Aviga. It's web-based, software as a service, so they're all linked up via the cloud, if you want to call it that. That means we can actually analyse almost in real time what's happening across all of these clinics, and we hope by the end of the year to have about 13 with about 20,000, 25,000 patient records. So we would be able to do an awful lot of linked working between clinics that were originally siloed to look at research, audit and benchmarking, create things like on the right-hand bottom side, right-hand corner, dashboards, for instance, will tell individual clinics how they're doing related to their outcomes in terms of their patient care, but also how, for instance, they may compare to other clinics or the national average and so on. And I think that's also going to be extremely important for payers in terms of looking at how outcomes are in a real-world setting, what outcomes are there for certain treatments. What in HIV is resistance still a big issue for certain types of patients. What about all types of morbidity and so on as people are getting older, and so on and so forth. And without having an infrastructure in place and having a motivation to be able to generate insights and reward evidence from this real-world data, it would probably be pretty hard to do in a traditional setting. Very similarly, I think it's really looking at a quid pro quo model of data access from multiple stakeholders. So we're actually looking at a networked consortium of clinical centres around research on audit and benchmarking, but meanwhile the overall data set may be of interest to third parties, not just industry but payers and government, academia, non-governmental organisations and patient groups and so forth. And we could generate insights from clinical practice, longitudinal patient data of many to maybe a couple of decades now, but embed these studies within a real-world cohort. Already heard earlier about modelling inclusion and exclusion criteria, for instance, to pragmatic studies, but also evaluating natural history, real-world outcomes, and resource utilisation, all stemming from real-world data that comes from electronic health records, which is collecting data on a daily basis from clinical practice. And so we have technical systems in place, we have motivations, but clearly, most importantly, all stakeholders are aligned on doing this. So the last few slides before I kind of finish up for questions is, how do we collaborate with mutual interests in real-world evidence? Well, clearly there needs to be a need, and that stems back to Stefano's point about, is there a question that needs to be answered, and could this be done collaboratively? Site selection is a partnership; it's not just a transaction, and I suspect that may fall into play with registries like the one for Huntington's disease, we just heard about. Is there something around mutual intended use and sharing risk as well as the goals in terms of accessing this data? And it can be a bit complicated. It can be quite challenging at first to do this if you've not done it before. We often work with centres not just for our electronic health record, but also with things like registries and so on that we've worked on where there are no other programs like this, and that's actually quite an advantage because you're starting fairly afresh, but you're also doing everything for the first time. Piloting and learning fast and failing quickly is also important, and not necessarily having a big bang approach. Can you do a number of small pilots that grow together like a stepping stone approach? need to develop a flexible architecture that was already mentioned earlier again by Jenny. Have some early wins on both sides. Can we show some advantage from accessing this data from the clinician's point of view and or the patients, but also from ourselves and industry, and ultimately, so some peer and external recognition. Can we generate things like publications and so forth that show some meaningful insights from real-world practice and real-world evidence ultimately linked to outcomes. So there is some steps you can take around collaboration, which ensure they build around mutual interest, which is again not just based on a financial transaction of just buying records or buying data. So the answer may or may not be obvious if you're not following this. I love this slide where there's an exam response, it's literally apparently true exam response, find X, and someone's seen here instead of hypotenuse on the triangle, they've just said here it is. Sometimes it can be obvious and sometimes it's not that obvious, and you have to work closely with lots of multiple stakeholders, both internally and externally, to work out the best way to access data and to use it in the best way to generate insights. And ultimately, I think just some takeaway messages to think about that holy trinity, as I called it, the drug, diagnostic, and data. When we're talking about personalized healthcare, but really healthcare in general now is all three that are inextricably linked. Data has a life cycle within any organization, temporarily as well as from a location point of view, but start with a clear view on an intended use, the why, and understanding of both the what and the who, as well as the where and the when, are all important in terms of accessing real-world evidence and real-world data. And build data access relations on a quid pro quo, not only or at all on finance, but equity of and partnerships on access. There has to be a balance between those who provide data and those who receive it. And you've got to have the right capabilities in the right place at the right time, scalable to need. And in terms of from the payer perspective, much of this is still can be generated by payers, and increasingly we're starting to see bodies generate data of their own, even do studies of their own, but for the most part they are more and more still dependent on the industry itself, for instance, to generate data, and that has to be sourced more and more, I think, from a real-world setting to be credible and relevant. But certainly, those times have changed, and the industry itself, the pharma industry at one point, was very much in control of information on its own products, and that is no longer the truth today. And in fact, many others generate information on these products and our products than the industry does. But data is not pharma's usual product. It's a different language, different culture, and outputs in mild, and we kind of fail fast and learn quickly and hopefully move on from there. But ultimately, it's really not about technical aspects and technical solutions and machines. It's about people and the intended use, and we have to get the stakeholder point right so that we ensure that we get the best out of accessing real-world evidence and that we get the best insights to really inform and improve outcomes overall in healthcare. And lastly, I'll finish with a particular favourite of mine from W. Edwards Denning, who was really quite a kind of pluralist. He was working in many different disciplines and fields in the 20th century, but his quote, which is, "In God we trust, all others bring data." And I think that actually been used in a reimbursement conference by a payer recently, I think a few months ago as well, that I attended, and I think that's equally true there. There has to be some implicit trust and credibility of data, particularly in a real-world evidence setting, as it's fairly new, and from a payer perspective, as it were, they increasingly want to see this type of data and are incorporating things like health technology appraisals, reimbursement decisions, and so forth. And it's extremely important that we see this increase in terms of access, but also the quality and credibility, and ultimately, we'll see more and more that how we actually manage and provide healthcare will be based very much on real-world outcomes, not just clearly, obviously, on clinical trials. And I'll stop there. Quick tour de force through my presentation a bit earlier, clearly in the agenda, but happy to take any further questions. But thanks very much, Katerina.
Thank you very much, Nigel. It was really, really interesting presentation. And now I would like to open the Q&A session one more time. As I mentioned before, the same procedure of posing question applies to this session as previously. And it seems right now that we have one question for Nigel. and I guess we can see it on the screen. Except of the health economics and outcomes research questions, what part of pharma company could also be helped by this real-world data? I don't know if that's a proper question for you to answer.
That's a great question, and I didn't have time and didn't go through that in any detail in the presentation. But I think there are many now who are involved across not just Janssen as an example, but many all companies really, where real-world evidence touches on this from a health economics and outcomes research perspective. Clearly, this has an impact on market access, pricing, and reimbursement, value. And dossiers and so forth, but increasingly we need real-world evidence from an early development point of view. So implicit understanding of a particular disease area. So to use the example again, Jenny and the Huntington's disease registry, that's a great resource, I would suspect, in terms of early to late development of new therapeutics, where you can access data that can inform you about the natural history of disease, interventions and outcomes. Maybe you link that to samples, so you have well-characterized samples based on the the context, the phenotype of an individual or a patient. That's extremely important, I think, increasingly, especially as we move to more biomarker-led clinical development. So we need to understand much more about the biology of individuals with a certain disease. Epidemiology, of course, and burden of disease, understanding the unmet need, of course, and but also how globally, as we're now looking at diseases more in a global sense, how this is impacting in different parts of the world, geographically, different subpopulations and so forth. I think in clinical trial management, we're moving to obviously being able to model inclusion and exclusion criteria, as mentioned a few times today. That's extremely important, as we know that studies are extremely expensive. It can be very difficult, depending, especially in smaller disease areas, to enroll patients, and that could really impact on the success of a trial, if not a new product. So being able to model that in advance in a real-world cohort, as it were, extremely important. I think increasingly as we go forward. In other areas and settings, I think in terms of kind of real-world data, real-world evidence, I think also in conducting studies, maybe we don't have to do so many phase 4 studies. So after market authorization and the product's in the market, we may be able to use larger scale cohorts where the data is already collected, and be able to do these studies nested in that kind of cohort versus doing a fully fledged new phase 4 study, which actually could be much more economical, but also again linked to what's actually happening in clinical practice. So I think those are just a few, but there are many different aspects and areas where I think this type of approach, real-world data, will certainly improve upon what we do. And one other I should mention, of course, is becoming very topical, particularly EMEA, but the FDA is also talking about adaptive studies. So where we can actually start to see patients receive a new drug therapy really much earlier than after phase 3, but that's linked to the fact that they're involved in, if you like, a real life study, which is still generating longitudinal data, follow-up data, which is then informing the submission process for full licensing of the product. And there's work going on at the EU level. Certainly FDA is looking at this, but increasingly we'll see a hybrid approach, I think, to what we traditionally did with clinical trials and involving and incorporating real-world data. It won't replace clinical trials, and real-world evidence, real data is not a replacement for that type of work, but it certainly will enhance and adapt and optimize what we do in terms of clinical trials as well. So again, I think that's another big trend that we'll need to watch.
Okay, thank you very much, Nigel. I hope it was sufficient. And now we have another question for you, and that's I have read your interview with the organizers. Yeah, and I would like to ask you to broaden the question about real-world data, Europe versus USA, how it actually is. Who is catching up?
Excellent. No, that's an interesting question. It sounds like a football game, doesn't it? Real-world data, Europe versus USA. But
yeah.
Certainly, clearly there are some similarities, but there's a whole lot of differences as well. I think first and foremost, going back a bit, Europe has gone through a more of an evolutionary process of incorporating, for instance, electronic health records into clinical practice. Much of this has been top-down, government-led. We know, for instance, in the Scandinavian countries, they're probably some of the world leaders now. Where everyone has an electronic record. It's got long-term, longitudinal data sets, and they can do all sorts of fancy work analysing this, very helpful. In the US, they've gone for much more of a Big Bang approach, of course, and really under the last 2 terms of President Obama, actually initiated by his predecessor George Bush, they looked to digitalize electronic health records, and this really has put everything front and center, I think, in terms of generating real-world data, alongside moves to look at cost effectiveness, which we've done for some time. NICE, ICWIC and other bodies in the European setting have been doing this for several years now. The US is catching up on that, I suppose, in terms of having to look at this. We don't talk about rationing healthcare, of course, but that's actually what we do. And the US is kind of waking up to this, of course. And it's for that, all of that you need data. And there's a lot of bodies now, commercial, governmental and so on in the US that are really pushing the agenda, I think, on this. I think more the question is how are we linking up between Europe and the USA in this setting of rapidly expanding digitalization and abilities to access data, and that is happening on a number of different fronts. And one of the key things here, I think, is standardization. One of the challenges, of course, is even in Europe, where we have multiple member states. Even in member states, you have multiple regions and different hospitals and so on, and in fact you can end up with systems that don't even speak to each other in the same language, and there needs to be a standardization so that effectively everyone speaks in the same terms, and that semantically we understand each other, and there are moves afoot. Many different initiatives, I think, are going on, but at the governmental level, European Union level, at the US level, down to within organizations, within industry, academia and so forth, which is looking to create standards so that we can share data that much more equally and ensure that the context is preserved and that the understanding remains the same, and that that data is still meaningful. And I think it's really more of these kind of questions versus who is catching up. I think in a lot of respects, everyone has to a degree caught up in it in many ways. We're just doing it differently, and we just have to ensure that we can get some standard approach between us all, so we can get some value. There are some great international registries and other initiatives that are similarly now, which are collecting data across many regions of the world, that have collected, in the surgery or cardiovascular space, and these are the kind of things we need to look to, so that we can actually start to see not just the differences in Europe and the US, but actually globally. What are the outcomes in Asia, in Australasia, South America, and Latin America, and so forth? How does that differences in practice and differences in reimbursement? How do they figure between all these different regions? And I think these are going to be very insightful and meaningful as we go forward.
Okay, Nigel, I guess that would be for a longer discussion.
Yeah, maybe another webinar.
Yeah, I guess so. Okay, so thank you very much for this answer. And we have another one. Nigel,
Okay.
What did you mean by holy trinity of drug, diagnostic and data?
Yeah.
Could you elaborate more on that again?
Sure, and I apologise if I didn't make it so well understood earlier. But effectively, especially from the pharmaceutical industry, no surprise. We produce drugs, therapeutics. I mean, you also in Johnson & Johnson, we're a bit wider than that. We have medical devices, of course, and so on, and consumer products and so on. But certainly, as Janssen in pharma, we produce pharmaceutical drugs, biologics and so on, for treating diseases and meeting unmet needs. Increasingly, it's become apparent, of course, you can't do that in isolation. You need diagnostics, of course. You need to be able to diagnose an individual that have that disease, that they should get treated with whatever disease. You'll probably need to do some baseline assessments. Whilst they're on treatment, you clearly want to monitor them. You monitor them for effect of the drug, but also for safety, of course, adverse events and so on. And you'll also want to evaluate outcome through diagnostics. Have they responded to the drug? Are they staying on that drug lifelong? Is it a short curative treatment, and then they can stop the drug, but you need to know the outcome, and you need to know that diagnostically. But actually, all of those transactions, all the diagnostics and so on, all result in points of data. But I think the trouble is we tend to look at this in silos. So, we're very, very drug-focused, drug-centric over the years, possibly not a surprise. being in drug companies and in healthcare. But diagnostics has never been a very well-funded area to date. That's changing as we realise, of course, that you can't have one without the other. And increasingly, payers are often asking, well, there's a new drug on the market, but how do I know which patients will benefit the most from it? Is there a companion diagnostic, for instance, or at least a complementary diagnostic? And what I mean by that is there a diagnostic that's in the drug label, so HER2 for Herceptin or HLA marking for abacavir in HIV treatment, for instance? You need to use that diagnostic to utilise that drug in the right patient. For a genetic marker, for instance. So payers are increasingly asking this, and the industry is increasingly now expanding its R&D programs to include these kinds of diagnostics and or complementary diagnostics. So they're not in the drug label, but they're used for disease management, like viral load for HIV or hepatitis B or C. You measure the amount of virus, and that tells you something about what's going on in the infection, but when you're on treatment, the absence of it tells you that you're responding. So we need all of those things to accompany the drug. And we need systems in which to pull that data out and to monitor the effect, adverse events, outcomes, and so on and so forth, which is good for us as the industry, of course, in the learning, but also great for payers because that will tell them more and more about what's going on in the patients they're funding, and the hospitals they're funding, and in terms of performance, hospitals will know what's going on in terms of outcomes in their clinical practice. All three are this holy trinity, as I say. All three combined, I think, will ultimately form the basis for what we call personalised medicine. Because if you don't have the drug, you have no medicine. If you don't have the diagnostic, you can't test anything, and you don't know what the outcomes are. And if you aren't collecting the data, you can't truly say really what impact you've had. And if you're not collecting any data, if you're not measuring, you can't change it. And we need also to be able to audit. So if guidelines say X, Y, or Z, you should do this in certain patients. Can we show the guidelines are right? But can we show that people are adhering to the guidelines and the right treatments are being used with the right outcomes? And ultimately, all of that is what I'm calling this holy trinity. But all of them are interlinked. I hope that's been a bit better explained.
Thank you very much, Nigel. I guess that was a good answer. It seems that we have no further question for you. We just got one comment from Jenny. She's saying that thank you for valuable insights.
Oh, thank you very much to Jenny and to Stefano as well. I think they've been all great presentations.
Yeah, okay, Nigel. So thank you very much for being here with us, and thank you for joining this webinar.
Thank you.
Okay, perfect. So now I would like to test something. We should have Stephanie Manson on the line, but I'm not sure if we will be able to hear her. Okay, I cannot hear Stephanie. So I'm really sorry for saying that, and I'm apologizing for this, but due to technical issues, we will need to skip the last speaker, Mrs. Stephanie Manson, and we have come to the end of our webinar. I hope that I will be given the permission from Stephanie to share her presentation. At least, dear attendees, you will have the slides of Stephanie's presentation. So on behalf of Kakushin Group, I would like to thank everybody for joining us, and I would like to especially thank our speakers who have been putting a lot of time to make this seminar as interesting and valuable as possible. We hope you have enjoyed all the presentation. If you are interested in any of our upcoming events, please visit our new website, kakushinwebinars.com, or join us on social media. Again, thank you very much, and we hope to have you on board again in the future. Have a great rest of the day.